Welcome to Daily Physics Conversation. Today we have two students, one from Brown University and one from NYU. Our topic is today waves, and today we're going to go over characteristics of waves. Characteristics only.
Amplitude, wavelength.
Can you give me a definition of pulse, Isaac?
So like the pulse of your heart, something.
Oh, he needs mine.
No, it's fine.
It's like something periodic.
I'm gonna give something periodic, and so I'm gonna give you a rope. Okay, so all right, I'm gonna give you a rope, and how can you create pulse? You move it up and down once, and you create pulse, right?
Give it a jump.
Good. You create a pulse.
Sure.
All right.
Like
If you
acceleration.
okay, if you keep moving up and down, if you keep moving up and down continuously, if you move it up and down forever, what are you making it?
A wave.
You're making it wave. So you're making it wave.
So like one of those heartbeat monitors, like but in
right. So this is a pulse. This is a single pulse, and this is waves. Okay. So it's keep going on and on forever, right? Okay. Good. So, what would be the differences between pulse and waves?
Well, a wave goes on forever, while a pulse ends after one cycle.
A series of pulse is what we call waves,
Yes.
right? Okay, good. And there are two types of waves, maybe more than two, but we're going to limit ourselves to. One is transversal, and one is
Longitudinal.
I'm sorry. One is mechanical, and one is electromagnetic EM waves.
Yay.
Mechanical needs medium, and EM waves needs no
medium. Well, EM waves are just a fancy term for light. For those who don't.
Okay, so light. And can you give me an example of mechanical waves?
So
water waves.
Water waves.
Sound
waves.
Springs.
Okay, good.
Springs count as waves,
All right, mechanical waves. There are two types, right? What are they?
Longitudinal and transversal.
Transversal and longitudinal.
Is EM wave transversal or longitudinal?
EM waves is transversal.
Wow. Now, what's the difference between transversal and longitudinal?
Okay, the transversal and longitudinal is
propagation is perpendicular.
Yeah, the propagation. Okay, so that
you're the student, not the teacher. Stop that trap of yours.
okay. So this is a wave. What type of wave is this?
That's a sine wave.
Okay, good. This is a transversal wave. We call it sine wave. Okay, sinusoidal. Okay, what is moving to the direction of this way, and what is moving at the direction of this way?
Oh, so the amplitude and the wavelength.
So this is information is moving at the direction of the waves, and the particles is moving. Particles are moving up and down, right? So what do we call it? We call that the particles, little particles that the rope made of, right? Oscillate up and down while the information moving at the direction of the waves, right?
Okay.
And wave transfer, a few things. Wave transfer, mass,
energy.
Info, and energy. Which one is right?
Energy, not mass.
Good.
I have a side question for those who might be concerned about it.
Right.
What's the difference between nodes and antinodes?
Oh, well, standing waves. We are not covering standing wave.
Oh, really?
Yeah.
Those are not
Yeah.
on the
Standing wave. Standing waves. Tomorrow you're gonna do standing waves.
I see. So we're doing moving waves, right?
The node and antinode we're gonna be covering tomorrow.
I understand.
Okay, good. And in fact, EM waves you're gonna cover tomorrow. Today we're just gonna cover characteristics, 5 characteristics of the waves. Okay, and longitudinal. How are you gonna draw the longitudinal? By the way, this is called crest, and this is called trough.
It's sort of perpendicular, so like.
No, it's parallel lines that are
okay.
Going through.
Oh yeah. Like a spring. Like a spring.
No, like sound waves.
Like a spring. Like a spring.
Oh, that's
Okay.
how a spring looks like. Right.
Okay, how do you make sound wave?
That's literally how a spring looks.
Okay. All right. I'm gonna make two waves. One is transversal. One is
longitudinal.
Okay. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Good. Can you give me if one? Okay. If I take the 1, right? If I take the point of 1, which one I'm gonna make it wave? Which point? 5.
Oh.
If I take 2, who's
6.
Good. If I take 3,
7.
7. If I take 4,
8.
good. So far, so good. So you can say that successive point to successive point is the wavelength, right? You don't need to say that, okay, crash to crash is wavelength.
No. Oh,
You don't
yeah,
have to. Yeah, you don't have to. Or trough to trough is wavelength. You can say, all right, 7 to what is a wavelength?
7 to 11.
Is a wavelength. Or 12 to what is a wavelength?
8.
8. Okay, so far so good. Okay, good. In this case, you call it, what do you call it? You see that, how can you, this is, what type of wave is this one? Sound. How can you create this one?
So this is
Come over here, Isaac. Create this wave.
okay.
Look at the camera.
Yeah,
Create
this
this
is
wave.
literally just a spring or slinky.
Oh, okay. No. Okay, sure, you can do that, but by moving your mouth, you can. That's right. Okay, that's what is happening. So whatever comes out, whatever.
Yeah, we're pushing some of the particles.
That's right. You are salting the molecules.
Whoa, assaulting, not the molecules.
Okay, sure. So you vibrate. So okay. So what happened? This air molecule.
Yeah, you're pushing the particles
Okay.
away in this sort of motion.
Short of motions. Okay, good. What do you call this one? What are you noticing? What are the difference between this one and that one?
Over there, it's less
Close
dense.
together and
So what are you going to call it?
crest.
No, well, okay, crest, but there's
Wow.
a high compression
Oh yeah.
Compression.
and then rarefaction.
Okay.
So how many wavelength you have?
You know.
Compression to compression, one wavelength,
Mhm.
and then compression to compression,
Another way.
another
Yeah.
wavelength.
Or we can
Okay.
name the
So
points
two
like we did
wavelengths.
over there.
Oh, we can name the point like we did over there. So 5 characteristics of wave. Can you tell me those 5 characteristics? Number 1,
Amplitude.
speed.
Oh.
Or it doesn't matter.
Wavelength, frequency.
Wavelength,
Period.
frequency,
Period and amplitude.
period, and amplitude.
Yeah.
Now I'll tell you a few things. Okay, the velocity of the wave. What would be the speed of the wave or velocity of the wave? If you
F lambda.
F lambda.
But why is that?
Because
Maybe
the
we can
velocity
define wave.
velocity is distance over time, right? So
Yeah.
velocity is d 1 over t. Velocity is d 1 over t is f, right?
And the wavelength is at lambda.
Right, lambda and f. Okay, good.
Okay, there we go.
All right. Wavelength.
Yeah.
Wavelength is what?
Lambda.
Wavelength is cycle over distance over
Time.
Wait, no.
distance over cycle.
Yeah.
Over cycle.
Dummy.
Frequency is
Time over distance.
No, cycles per second.
cycle over
Oh yeah.
Frequency and time. That would make it 1 over
period.
velocity.
Period is
1 over frequency.
time over
cycle.
Wow, this guy does not know his waves.
amplitude is
Bro would fail the exam.
upper minus the lower divided by 2. Okay. All right. So let's see. If I give you a wave, right? Okay. So now, all right. Let's see. I give you 2 pulse, right? I give you 2 pulse. Pulse number 1 and pulse number 2. Which one has a higher velocity?
How would you know?
Which one has, this is pulse 1 and this is pulse 2. Which one has a higher velocity?
You can't tell from the image.
Both of them have the same velocity. All right. So amplitude doesn't affect the velocity. Okay. Second quiz. I have 2 waves. All right. This is a small lambda. This is a big lambda, right? As you see that this is a small lambda. This is a big lambda. Which one has higher velocity?
It looks like the big lambda.
Well, the velocity does not.
Oh, yeah.
Velocity does not depend on lambda because
Well, it does.
if lambda is small, frequency big. If lambda big, frequency is small.
No, you don't know that. That's only true for electromagnetic.
That's right. We are referring to electromagnetic.
We're talking about mechanical waves today. Let's
Okay.
not cause confusion here. We can say lambda f is constant tomorrow, but not today.
No, we are covering both. Okay.
Really?
Yes.
Okay.
All right. So I'm gonna give you another example, Isaac. Come over here. Don't do that, Isaac. Come over here.
Come on, I'm just helping.
All right. Okay. Isaac, come over here. Okay. So Isaac is over here, right? No, over here. and you're gonna create an echo, right? You're gonna say something very loud.
Okay. Am I good to go?
Ready, set, go. Good. So it takes 0.01 second, right,
Yeah.
for the source, all right, to the wall. It takes how long?
0.01.
Find the distance between the source and the wall.
3.43 meters.
3.43
Oh
meters.
wow, that was fast.
That means you just moved the decimal point.
You are a loser.
What?
You are a big
Because it
loser.
has to travel both ways.
What he gave me is this one.
Oh, it's
He
actually
forgot to divide by 2.
it's 1.715.
1.7. Okay. All right. Good. It's 1.7.
Even
Okay.
I know that, and I'm not a physics major.
You are a physics
Okay.
major.
So how did you get 1.7? Come. Who, Brown or NYU, who wants to find? Okay. No fight. No fight. This is not okay. No fight. Okay.
Feathers have been ruffled today.
Okay. Good.
So is Risa's hair.
All right. Can you find how it is 1.7 and not 3.4?
Okay. So I'm not going to be like say nothing, but
Fast. No. Fast. Find the frequency.
okay.
T is 1 over f.
Well.
Frequency is 1 over t, right? Frequency is 1 over t.
That's not necessary.
No. Let's do it that way.
Okay. Can I show mine?
Okay. Yeah. Sure.
Okay. So we already.
No. Don't write it there. People are gonna see.
We already know that the speed of sound is 343 meters per second.
Sure. We're gonna use 331, but 343 is good.
Okay. So then we have time is 0.01 seconds, right? So D equals VT, which is equal to 0.01 times 343. But of course, this was specified not as the time it took to hit the wall, but the time it took for Isaac to hear it again. So that means that to find the actual distance from Isaac to the wall, then we would have to divide by 2. And this gives us 1.72.
Whatever it is, 1.7. Okay, good. Next problem. Okay, don't use 343 for this problem, because this problem has to do something else, and that is ray of light. Okay, the source is sun. Okay, and we know that when light changes the medium, what happened? This is air, and this is water. Yeah. Okay, so a ray of light, doesn't matter what color it is.
Yeah.
Okay,
It gets refracted.
it gets refracted. I'm not going to show the refraction right now today, because we are not doing refraction. Okay, so it's gonna be bending, but I'm not going to show the bending today. Okay, so what happened? Whose speed is higher?
Wait.
One in the air or one in the water?
Okay, so I know from personal experience the water is denser, so that means that in water light is probably slower than in air. But that doesn't hold true for all things. What is the index of refraction? Can you make that clear?
N is 1 and N is 1.33.
Yeah.
Can you give me
That's
the,
a quantified value.
all right, can you give me
what
the,
is index of refraction? Have you covered it?
no.
So can you just like do a quick
Yeah, the index of refraction for the light in the air is 1, and for the
No,
vacuum,
those are values, but like what is it?
okay, so this is the index of refraction. N is, okay, C over,
V. So that means that it's how fast that it
That's right.
travels compared to
That's
in a
right.
vacuum.
that's right. So N is C over, this is the index of refraction. What happened? Why index of refraction doesn't have any unit? Because C is the speed of, C is the
Yeah,
speed,
it's
and
more
B
of
is
a
the speed.
proportion.
It's more of a proportion. Okay. All right. Speaking of this, can you tell me? Good question. That was good question. Can you tell me the equation to find the speed of the ray of light in the air?
Well,
Which is velocity is
yeah.
C over n,
Yeah.
and velocity is
See,
C over n, and that is C is 3 times 10 raised to 8 divided by 1. So 3 times 10 raised to 8, and 3 times 10 raised to 8 divided by 1.33, and that gives you 2.3 times 10 raised to 8, right?
Wait, can I make one quick notice?
Yes.
So some of you might be thinking, wait a second, wait over here a minute. Well, if air is n equals 1, and the index of refraction is like a proportion of velocity in a vacuum to velocity in a medium, then would that mean air is a vacuum? And that's actually not true. the index of refraction for air is a little bit higher than
Then
1.
that's
But
right.
we approximated it's 1.
Yeah, I think it's 0.9 for the vacuum. Okay.
No, index of refraction is 1 for vacuum. For air, it's about 1.0033.
That's right. That's true. That's true. That's right. Okay. All right. Last problem I'm going to give you. What type of light is this one? Can you see it?
Red?
Red. Can you find the lambda?
Are we given anything?
That's it. That's all I'm giving.
Yeah, C is 3 times 10 to the 8.
That's true.
Wait, what?
Okay.
F is
C over. So velocity is
3 times 10 to the 8.
lambda times frequency. So C is lambda times frequency. So lambda is C over frequency. So C is 3 times 10 raised to 8. And F is
F for wavelength
3.84
is
times 10 raised to 14.
Yeah.
So about 790 nanometers.
Yeah.
Okay, so we finished the speed and now we're gonna finish the wavelength very quickly. So wavelength, I give you a equation. I don't know.
Wait, didn't we just do wavelength?
Okay, let's say this is 20 meters. What is the wavelength?
Oh, it's 10.
Okay, good. Can you give me the equations?
So,
Distance
over cycle.
cycle.
so 20 over 2.
20 over 2.
It
So
reaches
10.
that midpoint.
All right, good. All right, now let's do frequency and period at the same time. How about that? All right, I'm gonna give you. Do you have a better marker?
Yeah.
I'm gonna give you some wave. 1, 2, 3, 4. All right, let's make it a second. All right, can you give me the period?
Okay, okay.
2 seconds.
2
per
seconds.
cycle.
2
Per
seconds.
cycle.
2
So that
seconds.
means the frequency is half.
What is frequency? Okay. Shh. Can you use the red color, Ref? Can you use the red color to draw the period on the wave? Isaac, I'm going to ask you to do the next one. I'm going to ask you to do the next one. All right. Draw one period.
Okay, from crest to crest.
No. One period from the origin.
Okay, from here to here. That's one period.
Okay, good. So one period. This is what I was hoping you draw, and you kind of draw this. So this is one period. What is the one frequency?
1 over 2.
1 over 2. Okay.
Cycle.
So 1 over 2
Let's go,
hertz.
calculator.
Isaac, can you draw 1 hertz? Can you draw 1 hertz on this? Can you draw 1 hertz
What
using
do you mean by that?
draw
Oh,
1 hertz on the wave that I constructed?
okay.
So I have a wave. I want you to draw just this, starting from the beginning.
Let me just draw the axis of time. So you have 1 second, 2 seconds, 3 seconds, 4 seconds, 5, 6, 7, and 8 seconds right over here. Now you'll be able to see
Use the red.
that in 1 second we only cover half a cycle, or in 2 seconds
Very
we
good.
cover a full cycle.
Okay.
So, it's 1
So
over 2.
no. Can you use the red? Okay, good. That's right. Or maybe you should do that. Okay, that's it. Okay. Now, can you tell me? Now, do you think the period and frequency are the same?
No.
What second I should put over here so the period and frequency would be the same?
4.
One would do the work. 4 would do the work
No,
as well.
1 won't do the work.
Well, 1 over 1.
No.
1 over 1. 1 over 1.
There were 4 cycles, so 1 would make it 1 over 4.
No.
So
Cycle over
okay. 1
1 second.
and then 4 cycles, right?
Yeah. So 1 doesn't work.
Yeah.
1 doesn't work. 4 works. Yeah.
Are you stupid?
Oh, okay. So 1 doesn't work. Yeah. No. Okay, that was my fault too. Okay. So 1 doesn't work. 4 works. Okay.
You got it right on your head.
All right. The last thing, amplitude. Can you find the amplitude for this one quickly? Okay. This is 8. This is -2.
5.
Amplitude
5.
5. Okay. What is the midpoint?
See, I got it first.
What is the midpoint?
3.
3. How do you get 5? By the way.
8 minus -2 over 2.
8 minus 2 over 2, which is 5.
I'm just kidding.
Okay, finally, this is the final challenge, and this is between 2 of you. And I'm gonna hold the camera and let's see who wins.
I thought you said there would be no competition.
There will be competition. Why?
You listen.
Okay, shh. What is the skeleton? Y is equal to A sine B x minus C plus D. Okay, Isaac? And this is for Isaac. Y is equal to A sine. No, nobody gonna see it, so I have to write it there. So this is the diagram. This is the diagram I'm gonna give you. What is the diagram? Diagram is this. I have.
And you're gonna ask us to identify A, B, C, and D.
Yeah, I'm gonna ask you to put the values. Okay, so pay attention. There is a horizontal shift, there is a vertical shift, and there is other hanky-panky.
Yeah, do know that you can also take. Oh,
no. Understand the challenge.
No. This is written wrong. The B.
BX plus minus C. Yeah, sure. Not wrong. It's same thing.
No, it's
okay.
You can factor it out.
Yeah. Wait.
What did I just hear?
Yeah. Okay. All right. Sure. Okay. All right. Sit down. Okay. Sit down. Okay. So, are you listening? So, this is 9. This is 1. This is 1. Okay. And this is equilibrium. This is equilibrium. What should this one be?
5.
5. Okay. This is.
No, it's not. It's 6.
No, it's 5.
It's
9 plus 1 is 10. 10 divided by 2.
Oh.
Okay. Genius. Okay. Let's say this one is. Are you paying attention? Let's say this one is. This one is pi, and this one is 5 pi. Right? Okay. So this is the graph I have. The graph starts from here.
Come on, you got this. Just draw that sine wave. Hey, that goes under the minimum.
Wait, that is
Oh,
one down.
yeah.
Oh, that sounds like a fat fart.
Okay. All right. Okay. Come both of you and write the equations. Okay. Let me write it this one. Y is equal to A sine bx minus c plus d. Who wants to try first?
I'll do it.
Okay. Let's Isaac do it first and then rap. Okay.
So my thought process here is it looks.
I'll sit down here.
It looks like there is.
Oh, by the way, I didn't draw it to the scale.
Yeah. It looks like there is one cycle and then half a cycle here, right? That's true, or is it just
No, put all the 5 point.
Okay.
Put all the 5 point.
1.
I think that
No.
meant to draw one cycle.
Yeah, one cycle.
So
Don't put 2, 3, 4, 5.
Yeah.
Or 5 point.
Yeah. 5
Okay.
So
So
that's it, right?
yeah.
Okay.
So 5 pi. So what are all the point between pi and 5 pi?
Okay.
What is the middle one?
This one is 2 pi. This one is 3 pi. This one is 4 pi.
Okay, good.
It'd be pretty simple.
Congratulations.
So that means that the length from here to here is clearly 4 pi because it's 5 pi minus pi. So that means we already have the wavelength.
So no, write y is equal to. Write y is equal to. No. Underneath of what I wrote. Underneath of what I wrote. Okay. A is what?
So A,
Yeah.
we already know it's 4 because it's 5 minus 1.
It's not 4. Okay, 4. Okay, sure. 4.
Refat, can
Okay.
you tell me not?
Okay, it's 4. Okay, sure. Go ahead. No. Okay. All right. Okay, I'm not gonna tell you everything. Okay. Sine.
Frequency. So we just saw. So the normal frequency, sine x, has a period of 2 pi. Now this has a period of twice that. So we're going to make it 1 over that. So that means we have 1 over 2 pi. It also looks like we have a phase shift of pi. So I'm going to put a plus pi. Wait, did I put 1? Okay. And then we have plus d, which is just going to be the minimum, or wait, no, it's going to be the midpoint, which is 5.
Yeah.
What a loser. All right, Rap go. Okay, Rap go.
Wow. Okay, let's see.
Okay. Okay, Isaac sit.
I mean, okay, let me see. I feel like this is Let me just tell.
Oh no, this is second grade way. Alright, this is.
Okay, this is okay.
I'm
Fine.
taller than that. Look.
If I plug in pi, then I
Oh
get
no, I cannot do that in the
3
class.
pi over
Okay.
2. Sine of 3 pi over 2 is
First of all, this is -4. This is not +4,
What
by the
the
way.
heck? Wait, no.
Yeah, it's -4.
That's
It's
wrong.
going down.
That's wrong.
It's -4. +4 that's gonna go up.
He's right. He's right.
Okay. Alright, okay. Alright.
Okay, wait. Just one second. Don't tell me the answers. Okay. So this is 0 pi over 2 pi 3 pi over 2 2 pi, right?
You gonna do it primitively?
No.
Yeah, He's a stupid.
So
You're dumb.
here, if I plug in pi, I get sine of 3 pi over 2 is -1. -1 times -4 is 4. Plus 5 is 9. Okay.
Why don't you see this works for the phase shift?
It doesn't.
So,
It doesn't.
yeah.
It should be minus.
Minus, okay. Now it's still not gonna work.
Not your
It's still not gonna work.
Okay, so if I do this,
Phase shift. What is phase shift, by the way? What is phase shift?
phase shift,
You already have phase shift. What is phase shift?
pi.
Pi. If you write half at
It's half. X. Then pi over 2 pi.
Isaac, why don't you go against that?
One
No.
second.
Bring that or all of the goddamn above.
Let me finish.
Let you fail is what you said.
No, 2 pi. It should be 2 pi. Phase shift.
The two.
No.
Alright, write at once. What should be in the bracket?
Okay.
1/2 x
Okay.
minus 2 pi.
Okay. Let's
Or minus pi. Plus
shut
pi.
the hell up. Okay. We're just gonna plug in x equals pi and see what
Oh,
we
that's
get.
cheating.
No, that's not. You dumb little.
It's the class. I thought it's class.
Blah 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 blah. Blah 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 blah.
What is he doing?
Blah blah blah
That's,
blah.
he's trying to figure out what C
Blah
is.
blah blah blah.
I thought you just write half x minus c is equal to pi and find the c.
Blah 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 blah. Blah 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 blah.
Okay, that's it. Oh, that's it. Yeah, that's it. Yeah, that's it. Alright, now put it in the calculator and you're probably gonna get the same thing. Okay. So alright, -4. So what is it? -4 sine. -4 sine. Okay, so let's see whether you get it. Half x minus pi over 2 is equal to 0. Is that right? Okay, so half x is equal to pi over 2. Multiply both sides by 2. So you get x is equal to pi. Okay, so the shift is pi.
The interesting part of the lesson was calculating the phase shift and writing the general equation for this sinusoidal.
The most interesting part of this lesson was beating Refast. No, I'm just kidding. I agree with Refast on what was the